Let's look at Chapter 4 notes. Chapter 4 is probability. We start with the definition of a probability. A probability is a numerical value ranging from 0 to 1 that represents basically the likelihood of an event occurring. So when we talk about probability, we talk about the likelihood of an event to occur. Very, very important to know that when we assign probability, we can only have values from 0 to 1. You can never have a negative probability, and you cannot have a probability that's above 1. We have 3 methods of assigning probability. We have the classical probability, where it refers to the situation in which we know the number of possible outcomes of the events of interest. This probability is determined by dividing the number of possible outcomes of an event by the total number of possible outcomes in a sample space. That means that each outcome will have the same probability of occurrence. Empirical probability observes the number of occurrences of an event through an experiment and calculates the probability from a relative frequency distribution. So it's you basically calculate the relative frequency for each outcome. And then the subjective probability relies on people's experience and intuition to estimate the probabilities. A subjective probability is made when classical and empirical probabilities cannot be calculated. For one reason or another, you do not have access to existing data or outcomes, and you assign probability based on your own intuition, background, education, experience, and so on and so forth. The law of large numbers states that when an experiment is conducted a large number of times, the empirical probabilities of the process will converge to the classical probabilities. The more you repeat an experiment, the closer you will get to the actual probability of the event. An experiment, now some definitions. An experiment is any process that generates well-defined outcomes. For example, when we roll a dice, pick a card from a deck of cards, and flip a coin. The sample space is the set of all experimental outcomes, all possible outcomes that can occur from an event. For example, the sample space, when you toss a coin, it's either going to be head or tails. A sample point is an element of the sample space, any one particular experimental outcome. When you roll a dice, for example, a sample point can be a 5 or a 4 or a 3. Simple probability refers to the likelihood of a single event occurring. So in order to calculate a simple probability, we take the frequency in which the event has occurred over the total number of observation. When we talk about a complement of an event, are all of the outcomes in the sample space that are not part of the event of interest. So when you calculate the probability of an event plus the probability of the event not to occur, that's its complement, then that should add up to 1. If you have 1, you can find the other using this equation. Now, a contingency table indicates the number of occurrences of events classified according to 2 variables. Marginal probabilities are simple probabilities found by using the total occurrences in the margins of a contingency table. So let's look at this example, and these are tables that you will see a lot in this chapter. The following table is given. You have the majors, and you have, this is data that we have collected based on majors and based on the different types of students, if they're undergrad or graduate students. When we have a table, the first thing we do is we want to make sure that we have the totals of every column and every row, including the grand total. The grand total is where the totals basically meet, and this is the total number of students, in this case, that have been interviewed. Now, we want to calculate the probability a randomly selected student to be a business major. Business major, you go to the total. What is the total? 200. What is the grand total? 200 over 500. So the probability of selecting a business major student is going to be 0.4. Calculate the probability a randomly selected student to be a graduate student. You go to graduates, you go to the total of that category, you have 100. 100 over your grand total, which is 500, 1/5, that's going to be 0.2. We want to calculate the probability a randomly selected student to be a graduate business major. Graduate business major. That means I want both characteristics at the same time. When you're looking for the probability of both characteristics occurring at the same time, you will take the point of intersection of these two characteristics over the grand total, which means graduate business. Graduate business. Where do they meet? Right here. So the point of intersection is 50. 50 over the grand total, this will be 0.1. This is where the 0.1 came from. Now, calculate the probability a randomly selected student not to be a business major. Not to be a business major. So what are we supposed to do? You will take the probability of not business will be equal to what? 1 minus the probability of being business, correct? So business and not business are basically complement events. We use the formula that we had before. So the probability of selecting someone that's not a business major will be equal to 1 minus the probability of selecting someone that is a business major. We already have that probability from here. So 1 minus 0.4 is equal to 0.6. 0.6. Now, the intersection of events A and B, which is the probability, this is how we write it, of A and B, represents the number of instances in which either event A or B occur at the same time. At the same time. There's an intersection of the two events. The probability of intersection of two events is known as a joint probability. The union now of events A and B, that means probability of A or B, represents the number of instances in which either A or B, events A or B occurs, or both events occur together. If the events are not mutually exclusive, that means they have a point of intersection, then this probability of A or B, will be equal to the probability of an event A plus the probability of an event B minus the probability of both of them occurring at the same time. Again, this is for not mutually exclusive events. If the events are mutually exclusive, that means they cannot occur at the same time. The probability of A or B is simply the addition of their corresponding probabilities. In this case, probability A plus probability B. Let's look at this example. Once again, we have our majors, undergrads, and graduate students. We have the totals of each category, and we have the grand total, which is the total number of students that were interviewed. Calculate the probability a randomly selected student to be an arts science major or an undergrad student. So I want arts and science or undergrad. So this probability, since they can occur at the same time, there is a point of intersection between the two events, will be probability of arts and science or undergrad will be equal to the probability of selecting an arts and science plus the probability of selecting an undergrad minus the probability of occurring at the same time. I have to take this out because I'm looking for the probability of one event or the other, not both. And since there is a probability that those two events can occur at the same time, I need to subtract that from my probability. So the probability of selecting an arts and science major is, you go to the total over the grand total, 125 over 500, plus the probability of selecting an undergrad, you go to the total of that category over the grand total, minus the probability of both of them occurring, arts and science, undergrad. Where do they meet? Right here. So you will take this number over the grand total. If you do your calculations, this probability is 0.85. Calculate the probability a randomly selected student to be an engineering major or a business major. If you notice from the table, these two are parallel, so there's no point of intersection. Therefore, they're mutually exclusive events. When I have mutually exclusive events, the probability of one or the other is equal to the addition of the corresponding probabilities. So in this case, the probability of selecting an engineering or business will be equal to the probability of selecting engineering plus the probability of selecting business. What is the probability of selecting an engineering major student? Engineering, 175 is the total over the grand total, plus the probability of selecting a business. Business is 200 over 500, so the probability will be 375 over 500, 0.75. Prior probability is the probability of event A occurring without your knowing any additional information that could affect the event. Conditional probability is the probability of an event A occurring when you know that event B has already occurred. Conditional probability is also known as a posterior probability, and this is the formula for the conditional probability. What I want you to remember is whatever follows this line, right, means that I'm looking for the probability of A given that B has occurred. So whatever comes second has already occurred. So how do I read this probability? The probability of A given B has occurred is equal to the probability of A and B over the probability of the event that has already occurred, which in this case is B. Or the probability of B given the fact that A has occurred is equal to the probability of A and B over the probability of A, since this is the one that has already occurred. So let's look at this example. Tammy is a general contractor and has submitted 2 bids for 2 projects, A and B. The probability of getting A is 0.65. The probability of getting project B is 0.77. The probability of getting at least one means one or the other, is 0.9. So if we were to write down the probabilities given, this is what you would have. Probability point A, 0.65, probability of B, 0.77, probability of A or B, 0.9. So the probability of A or B, since those two events can occur at the same time, will be probability of A plus probability of B minus probability of A and B. I want to know the probability that both of them will occur, so I'm looking for this probability. So you will take this equation and you will write it as this probability being the unknown. So if you were to rewrite your equation, the probability of A and B, solve for the unknown basically, will be 0.52. You substitute the probabilities that you know and the one that you're solving for, and you will find the result. Now, what is the probability of getting project A given, this is your magical word that signifies that you have conditional probability, that you got project B. The most important thing here is to write the probability you're looking for correctly. So what am I looking for? The probability of getting A given that B has already occurred. So this will be equal to the probability of A and B that I have just calculated, 0.52, over the probability B, which is 0.77. and your answer will be 0.675. Now, what is the probability of getting project B given that you got project A? Now we're switching it around. That means that this will be equal to the probability of A and B, which remains the same, 0.52, over, however, the probability of A, that A has already occurred, 0.65, so the answer would be 0.8. Now, the multiplication rule is used to determine the probability of the intersection of two events, or probability A and B, otherwise known as the joint probability. Before you apply the multiplication rule, you have to determine if the events are independent or dependent. What do we call independent events? Two events are considered independent of one another if the occurrence of one event has no impact on the probability of the other event. Therefore, if the events are independent, the probability of A and B will be equal to the probability of A times the probability of B. If the occurrence of one event affected the probability of the other event, the events are dependent events. If the events are dependent, then the probability of A and B will be equal to the probability of B times the probability of A given the fact that B has already occurred because they are dependent. Or probability of A and B is equal to the probability of A times the probability of B given the fact that A has already occurred. So this is your formula for dependent events. This is your formula for independent events. A jar contains 5 white balls, 6 blue balls, and 4 red balls. You randomly select 2 balls. What is the probability that the first ball will be red and the second ball white? No replacement. So since you select the balls without replacement, the events will be dependent. As a result, the probability of the first ball to be red and the second one to be white will be the probability of selecting a red times the probability of selecting white given the fact that you have already selected a red ball. So 4 over 15, since you have 4 red balls, times 5 over 14. Why 14? Because I have already selected a ball. So you're going to have 1 less from the total. So your probability will be 2 over 21, 0.095 for the probability. What is the probability that the first ball will be blue and the second ball also blue? No replacement. Since you select the balls without replacement, the events will be, again, dependent. As a result, this will be the probability of the first ball to be blue and the second one to be blue will be equal to the probability of the first ball to be blue times the probability the second ball to be blue, given that the first one is also blue. So 6 over 15 times 5, 1 less blue ball, over 14, 1 less ball. So the probability will be 2 over 14, 0.143. Now, what is the probability that the first ball will be blue and the second ball blue with replacement? That means you pick one ball and then you put it back. So therefore your events are independent. So the probability of selecting the first ball to be blue and the second one to be blue will simply be the multiplication of the corresponding probabilities. So 6 over 15 times 6 over 15, 4 over 25 for a probability of 0.16. And this concludes our notes for chapter 4.